Welcome to another electro-technology video. And in this video, we're going to learn how to use the battery drill the correct way. Let's have a look. As electricians, one of our main tools is the battery drill. We use the battery drill for drilling holes and as a screwdriver. It has quite a few different functions, and I'm going to go through some of those with you in this video today. Firstly, let's look at the settings of the drill itself. So I have two speeds. I have a slow speed and a fast speed, 1 and 2. So if I put it onto the slow speed, that's about how fast it goes. If I put it onto the faster speed, it goes a bit faster. You probably can't tell the difference. There is actually a difference there. But the main thing is that the slower speed has more torque. So if you're trying to drill into really hard timber or some other hard material, you might use the slower speed. Most of the time, I personally don't use the slower speed, but there will be times where I might have to use it. I also have 3 settings for the actual drill, the way it might work. I have a screw setting, a drill setting, and a hammer drill setting. And a hammer drill is if I've got to drill into concrete or brick, and obviously the others are kind of self-explanatory. One is for drilling, one's for using as a screwdriver. I also have torque settings. The torque settings are the setting that allows you not to overdo something. So if you're driving a screw into softer material and you don't want the drill to continue going through one at a certain point, then the torque setting will stop it from happening. So for example, I have this on torque setting number 1, and if I pull the trigger, it works. If I hold onto the chuck, you can see it's not turning. And that's because the torque setting is so low that if I was drilling into something soft, that resistance would actually stop it from working. I generally have that turned all the way up. As electricians, it's always a good idea to get used to using your battery drill by the trigger, because it should be variable speed. If you can do that, it's going to be quicker for you on the job. You don't know what the torque might be of a particular material. So the torque settings, as good as they are, they probably don't help us very much as electricians. So I generally just keep it all the way up, turned up to the top. I'm now going to demonstrate how I might use this drill. So obviously with a battery drill, batteries, this particular battery actually lights up and tells me how much battery charge is in it. It's always a good idea to make sure your batteries are always charged. This is a 3 amp hour battery. The larger the amp hour, the more work you're going to be able to get done, the longer it's going to last. So if you've got battery drills that only got 1.5 amp hour batteries, they are great for just doing the odd job here or there around the home, but probably not so good if you're out working on a building site. So the bigger the batteries, the better. To change the drill bit, depending on what I'm doing, to do this, you basically put your battery drill into reverse, hold onto the chuck, and then slowly pull the trigger, and it will come open. Then I can put in a different type of drill bit, and I put the drill into forward, and hold onto the chuck, and slowly pull the trigger, making sure that I'm actually keeping my fingers away from the drill, because that's a cutting edge and that could potentially hurt my fingers and injure myself. Don't try and do it at full speed. If you try doing it at full speed and grabbing hold of it, it's going to burn and hurt your hand, so please don't do that. Okay, I'm going to start with just drilling into some timber. I've got a drill bit here that can drill into timber. Here is my piece of timber. When I'm out on the job, I'm not going to have a vise. It would be nice if I did have a vise, but I'm not going to have a vise. So I need to use what I have available to me. Now, I may be able to hold onto it like this. I may be able to press it up against myself so it doesn't move, because when I'm when I'm drilling, I don't want this to spin around. If I have a clamp, even better. Always good to have a clamp. I can use a clamp, and I can clamp it to any particular bench or anything that might be available for me, just to help stop that from moving. Now, most importantly, safety glasses. We cannot do any work without safety first. So, on go my safety glasses. If I was drilling into brick, I would want to wear some sort of hearing protection as well. some ear defenders or earmuffs, something that's going to protect that hearing, because it's really, really loud and your hearing doesn't get better, it gets worse. So please protect your ears. Okay, with my safety glasses on, my drill, I have it in the forward position. Always double check that it's in the forward position, and I can now drill into the timber. Being mindful that when I drill, that I am not drilling into anything underneath. I make sure that this timber is clear, or whatever it is I'm working on, and I can choose my spot. Maybe I've marked it out previously where I'm going to drill. When I hold my drill, ideally, I want to make sure that it is as square as possible. I don't want it on an angle like this. I want it as square as possible. Some drills will even have a level, which is good for us because most of the time as electricians, you're going to be drilling into a wall or maybe into a ceiling. So you want to kind of level that up, square that up as best you can, and then you hold on to the drill with two hands, one hand on the handle and the trigger, the other hand somewhere else just to hold it steady. Some drills will actually have a handle attachment you can utilize those. And then we start very slowly until we've started making an indentation and the drill bit is going in the correct spot, and now we can drill all the way through. Easy, right? But what happens when we come to other material? That was fairly simple. If I have to drill into metal, things get a little bit different. And there are going to be times when you're going to need to do this. Firstly, metal is much, much harder than timber, so it's not going to be quick and easy. The other thing I'm going to need to do is, because when I try to drill this plate, my drill is going to want to move. It's not going to bite nicely into the timber like it did there. It's going to want to move around. And if I'm trying to be precision, then that's the last thing I want. So I will need one of these. This is a center punch. So once I've marked out where I want to drill, I take my center punch, place it on the exact spot that I want to drill, and then I hit it with my hammer. That will then make an indentation, which I can use my drill to start drilling. It'll stop the drill from moving and wobbling around. So I'm going to demonstrate this. The other thing you want to do as well is you really do not want to hold on to this with your hands. Metal is sharp, it has sharp edges. It will hurt and you will have an injury if you try holding on to this with your hands. So you need to use something else, whether that be a clamp, whether that be your pliers. These are great tools. So if I was to hold it with my pliers, again, I'd be holding it in such a way that it's not going to spin and hit me. Okay, it's also clear of any other object, so I'm not going to, make any damage anywhere else. So if I take this without the center punch, when I try to drill, my drill is actually moving around, which is what I don't want it to do. So I need to take my center punch, find my spot, give it a tap. Generally all you need to do is just one tap. If it's really hard metal, maybe more than one tap. Now, when I do this, and again, I'm going to do it with my pliers just to show you how I do it actually out on the job. What will happen is my drill will no longer move around. Now, this is really thin metal. So as I'm trying to do it here, it's actually flexing, which isn't going to help me at all. So I would really need to put this somewhere so this isn't going to bend, so I can just drill straight through this metal without any major issues. If I'm drilling into concrete or brick, I don't need a center punch, but I'm not going to use this drill bit. I want to use a masonry drill bit. And the masonry drill bit has a slightly different head on the end. It actually has a tungsten tip, and it's actually quite blunt, but it's designed to cut through concrete and brick, because when I put my drill onto the hammer function, because otherwise it's not going to work, what will happen is the drill, not only will it twist, but it'll also try to hammer as well. So it smashes its way through that brick. If you put these drill bits on and you put your battery drill into the hammer function, it'll only work with brick. It's going to make an absolute mess if you try drilling on any other material. We do use masonry bits, sometimes to drill through tiles, although some of the tiles can be really, really hard, and there are special tools, special drill bits designed for cutting through tiles. That is really it for using a battery drill. There isn't a lot to it. Remember, safety first, keeping your hands out of the way, using something to hold the material you need to drill through, making sure you've got your safety glass on and wearing some sort of ear protection if you are drilling into brick or concrete. Even if you're drilling into metal, it can get really, really noisy. You should always wear something on your ears. That's it for this video. I hope you got something out of it. I'll see you next time.